All right, good morning, everybody. I know it's morning and some of us are a little tired. So, at least for today's class, I'll ask that at the start we have our cameras on, so at least we get to see who's in class with us. We get to see each other, we get to form that relationship because we have to work together for the next year or so. So, if possible, right? As you would have seen on the note, unless absolutely impossible, I would prefer that you have the cameras on for today's session. Are you able to hear me well? Can everybody hear me well?
Yeah.
All right, awesome. Nice. So welcome to maths class with me. We move under the banner of Samari tutoring now. And that's really just a partnership between myself and another tutor. I will be your main tutor. There'll be only very rarely, and I don't expect this to happen, but we never know, we can't predict the future. May you have a substitute teacher for a particular class, but generally I will be the tutor for this class. And I think you're going to have a good time. I expect that you're going to enjoy being here and learning with me, and I'm really hoping that you all give it your all. You don't have much time if you're writing in January, and you also don't have much time if you're writing in June. So it's a lot of work from here till, and well, as I probably didn't tell you, but yes, you're going to be writing in January and June, right? So it's not a lot of time that you have. It's going to be a lot of work. And whatever you put into this maths effort, you will get out. I am positive. I've seen it before. Once you put in the work, you will get the correct result. I could say from here too that I make myself very accessible to my students. There have been times where I was in taxis correcting work that people send, checking over questions, and that's the kind of support that you'll get if you're that interested. There have been students as well who've not been very interested and who have been shocked by the kind of result that they would get. But as I said, if you don't put in much work, you're not going to get a favorable response. So let me let you all know, yeah, that is the kind of level of support you will be getting from me, and you can look forward to that, right? So we're just going to go over just all the basically the class rules and those sorts of things. We are also going to start working today. Yes, today's a working day. We're gonna do some introductory topics for your this first month, which is August. We're going to really make sure that you have the right foundation in the maths. What I have seen in other spaces is that people come into maths and they try to do a lot of past papers, but you need the foundational knowledge. You need the foundation. We need to make sure your foundation is stable. So if your foundation is stable, then we will have tested that and make sure. If it's not stable, then you will stabilize it in the month of August. So it's a very important month in terms of your maths, right? You need to be able to understand concepts in algebra, how x's and y's and how letters get in maths in the first place, right? And how they work about, because from this step on, everything else is assumed that you have this knowledge, right? So that is why I like to start at the very bottom, because everything else in maths assumes that you already know these things. So you're going to make sure that these concepts locked, and then we're going to build on them, right? So it's not, it's not going to be very stressful, but I want you all to understand where we started. If you feel that it's a little too basic, I'm guarding you against that. Do not feel so. That is, we start off at a very basic level and then we go, right? We want to make sure we can't overlook these things. We need to make sure that these elementary, these foundational principles are well understood before we go up into the more complex things. And trust me, I take a lot of time to build so that when it's time to plaster the house and to paint and thing is real rapid fire, so that I'll take real time to build, make sure the foundation is stable, and then it's speed. And when I say speed, it's not compromising the quality that you receive, but it's a lot of pace, right? And you'll be required to keep up. So let's just go through what would be expected in class. Okay, good. All right, so class will be every Saturday, 8:30 to 10:30 a.m. That's 2 hours. There may be instances where you might get a bonus class or extra class. If you're working at a topic that we really need to finish before the month is out, I will let you all know in advance. I want to have a class Tuesday. Those who can make it, come on. These class sessions are recorded. And I do not say that to make you comfortable and say, well, oh gosh, I could miss class, it's recorded. I am telling you, there is no better experience than actually being in class and getting to ask the questions that you want. Looking at a recording, you'll hear everybody else's question and you'll be saying, well, why didn't I ask this? Because you should have been there to ask that specific question, right? So there is no greater experience than being in class. It's also important because you're going to look at and ensure that, you know, your outcome matches the amount of times you come to class, right? So coming to class is fun, it's critical, right? So do not think that because you have these recordings that it is a case where, you know, I don't want to go to class, right? The reason I started this class with recordings is so that you could always look back the class, you know? So sometimes during the week when you have some time, make sure and look over the lesson, look over what was done, make sure and refresh yourself. I always try to tell my students, try and get in, it's a habit, it's difficult, but try to get in a few hours of maths every week, right? So if you decide 4 hours of maths this week, you could decide probably 1 hour a day for 4 days and so on. And then you start to build in terms of the amount of time that you spend on it, right? But definitely start to give yourself some time dedicated to study, right? An hour is not to be just spend an hour scrolling through Instagram and Twitter and so on. So an hour is not too much time. Right, so all classes will be here on Zoom. I find Zoom is a very, very useful feature, and you will come to see that there's a lot we could do here, and there's a lot we will do here. I have been having classes on Zoom probably 3 years now, so I am familiar with the online technology. And I want to say too that learning online doesn't need to be difficult. Learning online is actually easier than a lot of people think. It allows for a lot more flexibility, right? Physical classes, as I have seen, you need to be prepared to reach the class. Sometimes you're coming from work and it's a whole process in terms of getting there on time. So physical classes could sometimes be a little demanding on you. Online classes have a lot more flexibility, right? A lot of people like to do the classes, you know, you could pay attention to class while you're on your way from work, while you're doing any other thing, right? So online classes do offer flexibility and they should be just as interactive. But I keep reminding you that the level of interaction is based on you. I'm here to answer every question, I will, but make sure and engage me. If you don't understand something, please do not leave my class without letting me know that you don't understand. And I'm warning you from now as well, a lot of students love to do this, and I don't really take it on. A lot of students like to say, well, all right, yes, I understand. Yes, I understand. And after class, I get a message on my phone, well, you know, I don't really understand XYZ. I ain't having it. Talk to me in class. It might feel hard, difficult asking your questions in front of everybody, but the reason you're in math class is because you want to become better in the field. Don't study anything about how bad you might sound asking that. It is no competition, right? Because you might very well be helping somebody else who might have had the same difficulty, right? And I always say to another principal of my class is that this is the best place to get it wrong, right? You will come to understand that you ain't gonna get everything correct, right? As a matter of fact, going forward, you might get a lot of things wrong, right? But this is the only place you should get it wrong, not in the exam. right? So keep that in mind, that it's okay to get things wrong here. We will recover, we will learn, and we'll learn how to go around them. And as I speak about exams, it's a good time to remind you that I give a lot of exams, right? So that is to prepare you for your real exam. So don't feel like I'm in here and it's just CX here, right? Monthly assessments, I give monthly assessments, and sometimes I give spot quizzes and so on. That is to make sure that you're prepared. That is to make sure that you're ready, right? So that when the whistle blows to CXE, you're ready to go. You can handle any challenge. You're able to think on the spot. So yes, be familiar with assessments, exams, and I mark correctly. I don't like to say I mark hard. I just mark correct. If you get your points, you get it, but you have to prove that you know you want the points, right? So statements, working, all those things you would come to understand. Very important for me, right? So we continue in saying, let me tell you, right? So you would have noticed that you would have had to register for this class. If you didn't have to register to come on Zoom, please make sure that you go back after class and register, right? So that you can get the notifications every week that there's going to be class, when class has started, and when class would have ended, and any updates concerning the class, you'll get that via email and so on. Right, so you have the packet. Yeah, well, of course, paid persons and only you all. So what has happened? Online is a real terrible place, right? People just want to come to class and there's a whole village watching the session and I don't know, right? So I expect that you all who are registered here are the ones who be attending the classes, right? So that is what that was about. Edmodo, very important resource, and I'm going to share what Edmodo should look like. Was everyone able to log on to the Edmodo? I hope so.
Yeah.
Wonderful. Let me see. Edmodo is where all our class stuff will be. So let me just share my screen. All right, wonderful. All right, cool. So your screen, you all should be seeing my screen right now. Right here, Edmodo look like this. You can log in. If you have a mobile device, please download it. You will get like notifications when I post something, notifications when there are quizzes and so on. So on your mobile device, you can download it. For laptops, PCs, desktops, those things. You can also download Edmodo, right? So it's downloadable. You don't have to always go onto Google or whatever to look for it. But you should be able to download it and you'll get like notifications, right? So once you've signed up, you enter your credentials as my email, right? To log into your classes, and you should have, please remember your password, right? Because I have a lot of students who want to create 4 and 5 accounts because they forget the password. This is happened more often than you would think. So you would log on and it's something like a Facebook kind of vibe, if you look at it really. On your left, you should see the classes that you have. Now, I have a lot of classes, so you'll see a lot of different things here. But our class is Samari Csec Maths, this one right here. Oops. So enter it. You'll see a nice picture there. And all our class stuff will be posted here, right? If you look, you should be able to see agenda. Well, I could create the agenda, but you will see what is on the agenda. I didn't put an agenda for today because it's already an introductory class. But you will be able to see the agenda for class in the weeks ahead. Whenever you have a scheduled quiz, whenever you have an assignment to upload, all those things will be on your agenda. Posts, you'll see the posts like coming up like a newsfeed, and I'll show you one of my other classes so that you can remember that. folders. There will be folders with worksheets and all those different resources that I give to you all. So there's no need to go and buy no textbook for this class or to go and buy no past papers. You get all of that with me, right? So go out there looking and tell me, well, I got a nice test. Don't worry yourself. You'll get all the required worksheets and resources from me, right? So this is what your class would look like. Let me see if I find, yeah, so I had this class last year, right? And this is how it will look. I'll post the links from when we have class. Take a look at them here. You know, this is how it will look like when we start to have a lot of sessions, right? Whenever you have an assignment, let me see if I could find an assignment that they might have had. It's a lot, right? So right, so you see I posted a worksheet for them. You can click on the worksheet, you can download it, you have access to them there. Multiple choice quizzes, all this wonderful stuff. You'll get those things here. Right, so feel free to engage on Edmodo as well. Right, so you see our assignment here. Of course, I get to see what the assignments look like. Now, that is why I would have put in the instructions that I would prefer that you get an app on your phone that scans documents, because you have to scan and upload your work, your homework, or your assignments, right? Let me see if I could show you. Oh, a revision test, man. Okay, so this was the test that they had to do. Okay. And of course, on my end, I get to see what the submissions look like. Right, so I see people. So right, but yeah, good. So you get to upload your assignments there. I will correct them. You'll get a result, again, a notification. Your assignment has been graded, and of course, you always try to improve on those things, right? Quickly running through. Required resources, real important. You need a scientific calculator for this class. Need, right? So please ensure that if you don't have it for this class or by the next class or whenever, you have a scientific calculator. I don't think you need to buy one. There's always somebody who have a scientific calculator that they're not using. So please try and get a scientific calculator. A geometry set, please. Of course, you're on class because you have a device that works. Graph books, you will need graph books going forward. The scanner app, of course, your notebooks, your pens, your pencils, and so on. There's no need to get, as I said, past papers. You will get all those things from me. There's no need also to get any textbooks. All those things I will give. Please don't share the videos that I share with you in terms of the class videos, right? Again, that's not allowed unless we have a discussion in terms of that, but the videos are for you all who attend the classes only. So I don't expect to be scrolling on Facebook and see a video with me teaching a class that I wasn't prepared to have on Facebook or in any other place, right? How CXC exam would look like come next year. You have 3 papers to do, so keep that in mind early on. We have 3 papers, right? You have a multiple choice paper, paper 1. You have a structured paper, paper 2, and you have an alternative paper, which is that an alternative to the SBA, because you will not be doing SBAs. So you have an alternative to the SBA, unless I think Chad should be doing SBAs, right? But everyone else will have an alternative to the SBA, which is a paper 3, which is an anything paper, right? Paper 1 will come on certain topics. Throughout the syllabus, I think that paper 1 has the most amount of topics that will come. That's the multiple choice. Paper 2 is 10 compulsory questions. So long time when we did maths, it would have been that you could get to choose in section 2. I don't know if you remember that. In section 2, you could choose whether I want to do the matrices and the and none of that again. 10 questions are going to bring, all you have to do. Right? So and the paper 3, it's any topic from the syllabus. They could bring anything. So there's really no training for paper 3 on more than to know everything on the syllabus, right? Which you will, right? But long time, what used to happen is that the papers were relatively easy because you knew what was coming. You wouldn't know the exact question, but you know, all right, when you reach section 2, I ain't doing this the question with the triangle and then I ain't doing that. I doing the matrices and I doing this and you're looking for it, right? But now it's none of that, right? So that's what the paper would look like. If you have any questions for me about anything I just said, you can feel free to ask me now. If not, we're going to start getting to our work one time. All right. Like, if I explain everything well, who's me to ask or to send me any questions? All right, cool. Oh gosh. Oh, all right, cool. So yeah, let's get into it then. Today we're going to look at number theory. So that's the topic for today. And I'll just share my whiteboard in a little bit. Oh yeah, I give notes. Let me tell you, one time I just give notes, and I don't give notes for style, I just give notes for you to read, right? Because when you're going back over your work, I want you to be able to follow and you know that this is what we did. What has happened with maths a lot of times is that people just have a lot of working in the book now, and you go back home and you go to check it over and you're like, what I do here? Nah, I want you to remember what you did and notes to help that. So I do give notes, right? And I do give a lot of notes, and it's not for the habit of giving notes, it's for you to go over and to give your notes some structure. So when you're going over your notes, it's like, all right, this is what we did here, and this is what explains this, right? So don't kill me, but I do give notes. All right, just looking for the right file. Nice. I mean, I would have told you to, introduce yourself, but you'll get accustomed to each other. We have Amanda, we have Base, Chad, Nikisha. I think we have Tashana joining us from next week. There's a thing not really about that. Tashana joining us from next week. And this class will grow. There might be about 10 of us in this class. So look out for new people in this class, right? Let me know when you could see on my screen. See me right one? Right. Okay. All right. Just a note, your scientific calculator should look like this, right? There is, do not buy the little one. It's buy the one with more functions. If they ask you which one, tell them the one with more functions, right? Because then, you don't want to be left behind when you're doing things that require computational things that require you to use your calculator, and your calculator don't have the functions, right? So we'll look at number theory. All right, so when we counting, right? And we counting down from, let's say, 10, right? We don't stop at 0. And that's because we have something called the number line. And I'll draw for you a little idea what the number line is look like. At the center of that number line, we have 0. Right? And to the right, we have positive numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8. And on the left, so when we counting down, let's say 8, 7, 6, 5, 4, 3, 2, 1, 0. We don't stop there in maths. We now have -1, -2, -3, -4, -5, -6, -7, and -8 as well, right? So that in maths, when we're counting down or up or whatever, we must take into consideration that there are positive and negative numbers. Yeah? We don't stop at 0. For every positive number, you can take a note of that. For every positive number, there is an associated negative number. Right? For every positive number, there is an associated negative number. Now, these are really called integers, but we will come back to what integers are, right, in a little bit. But I want you to understand the concept of the number line. Cool. Now we're going to look at, so as I said, we'll come back to really understanding how to work the number line when we're looking at integers. And that will be next week. But for this week, I just wanted to remember to keep in mind that when we're counting, we don't just stop at 0. We have negative numbers, and that there's a negative number for every positive number, right? Oh, there are different types of numbers. Yeah. Counting numbers, so 0, 1, 2, 3, those things are called natural numbers. So natural numbers those are counting numbers. The symbol given to natural numbers is a capital N. Now, all these things are important, huh? It's important to note here that 0 is not a natural number. However, if we were to look at the set of natural numbers and include 0, we'll have something we call whole numbers. Whole numbers will be natural numbers together with 0. Symbol for whole numbers would be very simple, capital W. Good. Then something I mentioned earlier, we have integers. Integers are all natural numbers zero and negative whole numbers. So I want to, so as you realize, as I move from one type of number to the next, I immediately began to refer to them as what we learn them as. So we started off with natural numbers, then whole numbers consist of natural numbers together with 0, and integers consist of natural numbers, 0 and negative whole numbers. You want to look at integers in a very simple way. Integers is positive and negative numbers. So -1 is an integer, 1 is an integer, 2 is an integer, 3 is an integer, -3 is an integer, right? The symbol for integers is, you will think I, but it's not. Maths is a strange thing. It's Z, right? It's a capital Z. Yeah, let them vex already. Let's say, see, that why I'm thinking in my mind, that's why I can't take this maths thing. Yeah, I know what this be. It's a Z. So when you see Z now, when you see a capital Z, or when you see that in an instruction, you know that it's not the letter Z that might be referring to it. You know, and I'll show you how that will look like. You know, like if they tell you the set of Z is equal to something, you know, the set of natural numbers, right? So keep in mind that I'm giving you those things so that you remember, you know, what they look like and so on. Yeah. So we have now, because we're still learning about types of numbers. Rational numbers. Trust me, I'm working on the handwriting. It's something that's taken some years to develop. So. A rational number is any number that can be written as a fraction. Right? And it's important to remember that these include integers and decimals. Example. Three minus 1, 0, 1, 4, half, 2/4, 11/8, 0.75, and so on. Symbol for rational numbers is Q. Symbol for rational numbers is Q. If you need them to explain anything or you're not seeing something properly, let me know too, right? Please do not feel anything to interrupt me to ask a question. All right. Now, if we have rational numbers, we could have irrational numbers. And if rational numbers is any number that can be written as a fraction, what do we think irrational numbers would be? Nobody have an idea? Rational numbers can be written as a fraction. Irrational numbers will be what? I feel like well, I have it. I feel like well, they're saying it in another spirit. But yes, if you did say it, you are correct. Irrational numbers would be those that cannot be written as a fraction. So anything that's not rational is irrational, yeah? Two, 5 cube root of 12. Right, so these are some examples of some irrational numbers. Cannot be written exactly as a fraction, yeah. They don't have exact roots, if you want to call it that. Anybody knows what this first symbol here means? Anybody can remember?
It's a nice pie.
Mm-hmm. Pie, not macaroni pie, aloo pie, everything, right? It is pie which has a value. Anybody remember the value of pie? Nobody can remember the value of pi? 3.147 or 3.142, sorry, or 22 over 7. Remember that? I think remember 22 over 7. Yeah, well beans. Now, if I type in on my calculator 22 over 7, I get something that looks like that. No, I think you might be seeing the image. Let me see if I get the image. All right, so you should be seeing, right, should be looking exactly like what it is there. If not, then it's probably me or the video. But yeah, even if you're not seeing it, but you're seeing a long value there, and if you use your own calculator, you would understand. You're getting a value of 3.142857143. There's nothing recurring, so it's not like 3.666 recurring or anything like that. Yeah. And there's no predictable pattern of digits that recur either, right? Because it's 142857. It's not like 142434 and so on. Yeah. So irrational numbers do not exist on the number line because between any two numbers, let's say 1 and 2, there could be a whole lot of possibilities of irrational numbers. So they're not included on the number line, right? That's part of what gives it irrationality, right? That's something to remember. All right, next we're going to look at real numbers. Real numbers consist of rational and irrational numbers. Yeah. Good. So you will be required to remember these things, right? So don't take them lightly. Learn them, at least what they are, because I mean wouldn't require to realize how it come to what it is and not that isn't necessary. Just know what they are, right? Are we going to we are finished and we have plenty of numbers to I think we have some more to learn. Let's look at very old and familiar also I forgot to tell you that real numbers is denoted by capital R, right? So what is an odd number? Not a number that looks strange. though that might also be considered in some species an odd number. Anybody, talk to me. What's an odd number? I need to get some energy from the class now. I need to feel your vibe. Some point you must have come across odd and even numbers. So probably if you don't know what an odd number is, tell me what an even number is. Or give me an example of what an even number is. Where is this? Where is this? Nobody have an idea of an even number? Go ahead now, basic this one. So when we doing even numbers, I sure you remember 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And again, like going up the road because I have to remember all of them. Why do you think those are even numbers? What they all have in common? Nobody know what have in common?
All the even numbers could go into 2.
Right. They can be divided into 2. They could be cut in half. 2 could be cut in half, and not only they could go into 2 exactly without a remainder. Yeah. So that means if I have $2, I could divide it by 2 without having to give anybody change. Everybody gets an equal share. If I have $16 and I have 2 children, I could give each of them $8. Yeah. So even numbers are natural numbers that can be divided by 2 without leaving a remainder. And odd numbers are natural numbers. Well, if you're not even, you're odd. They are natural numbers that cannot be divided by 2 without leaving a remainder. In other words, odd numbers are bound to leave a remainder. All right, so we should be cool on that. So, I mean, examples include, if you need that, did we talk about those, bro? 2, 4, 6, 8, 16. 42. Okay. Odd numbers, 1, 2, 7, etc. Yeah. Now, and there's plenty to remember, but you will become like nothing after a while. We have prime numbers and the prime numbers. Anybody can remember what a prime number is? Nah, prime numbers you can't remember. And as a matter of fact, I want just for us to understand prime numbers, let me kind of segue to factors first. So we'll come to prime numbers in like 2 minutes. Anybody remember factors? A factor. What is a factor? Yes, I know. So a factor is a number that can be divided into, or as we say, a number that can go into another number without leaving a remainder. So a factor is a number that could go into another number without leaving a remainder. Yeah? So we could write that. A whole number and we go some examples. To be a factor, you have to be a factor of a specific number. You don't just be a factor, right? You have to be a factor of a number. So for example, 2 will be a factor of 4 because 2 could go into 4 without leaving a remainder. 2 will be a factor of 16 because 2 could go into 16 without leaving a remainder. 3 would be a factor of 9 because 3 could go into 9 without leaving a remainder. Understand? All right. So, I hope you would have taken on like those examples. Eh? If not, I could give them back to you. So 2 is a factor of 4. 3 is a factor of 9, etc., etc. Right? Now, I said that so that we could come to prime numbers because prime numbers only have 2 factors. If we look at, let's just say a bigger number, right? Like 12, right? The factors of 12 would be what? What numbers could go into 12 without leaving a remainder? Let's start look at it.
2, 3, 4, 6.
2, 3, 4, 6.
Well,
1 and 12, right? every number has as a factor itself and 1. Keep that in mind. Every number has as a factor itself and 1. Yeah. So 1 could go into 12 times, 2 could go into 12 6 times, 3 could go into 12 how many times?
4.
4 times. 4 could go into 12 3 times. 6 could go into 12 2 times, and 12 could go into 12 1 time. Yeah. I always like to list factors, because some big numbers, it is be difficult to think about all the possible factors, right? Because you're like, oh gosh, what's going on? So an easy way to I do it is to think about all the combinations of numbers that when multiplied will give me that number. So I know how to get 12. I could say 1 by 12 will give me 12. Yeah. 2 by 6 will give me 12. And I'm coming up the line. 3 multiplied by 4 will give me 12. I can't think of anything else, right? So therefore, these are the factors of 12. 1, 2, 3, 4, 6, and 12. Yeah? I was able to come to that. Yeah? So let's think of another number. Let me get another number. 42. What could be the factors of 42, Lord? Well, we know 1 by 42 will give me 42. Yeah? We know 2 by what?
21.
21 will give me 42. 3 by what? 3 by anything? Hmm?
16.
3 by 16? Now, don't be afraid to use your calculator in my class, huh? Well, 3 by 16? 3 by 16 is 48. Hmm? Now, think about if 21 could go into 42, 3 could go into 42 because
14.
3 could go into 21, huh?
14.
14. Yeah.
14. Yeah. I know.
3 by 14 is 21. 4 definitely wouldn't be a factor.
6.
Right? Sorry?
6 is a factor.
6 could go into 42 how many times?
7.
So we have 6, 5, 7. And here now we have all the factors of 42. Yeah? So that's a nice simple way that you could get factors, right? Now, prime numbers, as I was saying just now, only have 2 factors, and those 2 factors are themselves and 1. So prime numbers, sorry, not prime factors, because prime factors is something else. So a prime number is a whole number that has only 2 factors itself and 1. Very important to note. Prime number is a whole number that has only two factors, itself and 1. Anybody can think about any such numbers? Nobody can think about any.
2, 3.
Yes, so let's so 2 is a prime number because the only factors 2 have is 1 and 2, right? 3 is a prime number because only 3 could go into 3 and 1 could go into 3. 2 cannot go into 3, yeah? 4 is not a prime number because 2 could go into 4, 1 could go into 4, right? And 4 could go into 4. 5 is a prime number because only 1 and 5 could go into that without even I mean that. Then we have 7. Yeah. Then after 7, what we have? You can't say 9, I don't mix it up for odd numbers because 9 has 3 as a factor, right? So what's 10? No. 11?
11.
Yeah. And on until we have an infinite number. Yeah. Now 1 is not a prime number. For a very simple reason too, because a prime number by its definition only has two factors, itself and 1. 1 only has one factor, which is itself. Yeah? All right, so I hope everybody understand these concepts. Any questions on these things? If you have any questions. If not, we're moving on, right? So we're gonna talk about multiples now. So we have factors and we have multiples. Yeah? A multiple and you have to be a multiple of a number. So a multiple of a number is the product of that number, excuse me, is the product of that number, and product means to multiply. So let me put that in brackets. Is the product of that number and any any other whole number. One second. Let's make another table here. All right, cool. So sorry about that. Right, so I don't know why that happened, but anyway, I'll just show it. Excuse me. So if I have a number like 2, right? And I wanted to multiply 2 by 1. So I'm going on the line. 2 by 1, I'll get 2. And this is very similar to something we call what? Our tables, right? 2 by 1 is 2. And go, right? 2 by 2 is 4. 2 by 3 is 6. 2 by 4 is 8. 2 by 5 is 10. 2 by 6 is 12. 2 by 7 is 14. 16. 18. So multiples of 2 would be 2, 4, 4, 6, 8, 10, 12, 14, 16, 18, and so on. Yeah? Similarly, multiples of 3 would be 3, 6, 12, 15, 18. Hold on. Yeah. 6, 10 times 3 is 31. 8 times 3, 4, 27, right? 5 would be 5, 10, 45, yeah? And so this will go on for every single number. So the multiples of any number can be obtained by multiplying it by any other whole number, yeah? We understand this?
Yes, sir.
So in some ways, multiples easier than factors to remember. Now that we know about multiples and factors, I want to introduce us to two principles that, of course, you might have heard before as well, which is what we call, one is what we call the lowest common multiple, or the LCM, and the other is what we call the highest common factor, or the HCF. Yeah? So, the LCM, or the lowest common multiple, these things relates to more than one numbers. Because to be common, it has to be related to something. It has to be in common, right? So it relates to a set of numbers, right? A set could be anything greater than one. Two is a set of numbers, yeah? So the LCM and the HCF are related to sets of numbers, or more than one, two or more, right? So the lowest common multiple of a set of numbers is the smallest number that is a multiple of all the numbers in the set. Yeah, so that number must be a multiple of all the numbers in the set. So the smallest number that is common to all the sets is the lowest common multiple. So if I have two numbers, 3 and 6, the first thing I might want to do is to list some multiples of 3 and 6. Now, with multiples, we could go straight up the billions. Eh? So you need to do that, right? Because it's just 3 and 6. So we know they really didn't go too far. So the multiples of 3 would be 3, 6, 9, 12, 15. Let's just stop there. The multiples of 6 would be what? 6, 12, 18, 24, 30. We could stop there too. We want the smallest number that is common to both of these sets. That will be 6. Yeah? So the lowest common multiple here is 6. Now I always ask this question. Why wouldn't we want to find, why is it LCM and not HCM? Why is not the highest common multiple? Why do you think it is not the highest common multiple? Why do you think they don't make us find the HCM? Think about it, eh?
Because you now said we could go into the billions.
Right,
So might
exactly.
not be able to find it.
Exactly. It is impossible to find the highest common multiple. You go into the billion, you could tell me you would never know. And numbers are infinite. So we will never be able to find the HCM. Right? So that's the LCM. I want you to find the LCM. of 8 and 12.
$24.
Agreed?
Yep.
Yes, 24. Very good. Let's talk about the highest common factor. So the highest common factor, the HCF, again, refers to a set of numbers. Yeah, is the largest number that is a factor of every number in the set. The largest number that is a factor of every number in the set. All right, so let's look at two numbers again, 8 and 12. Factors of 8 would be 1, 2, well,
Four.
4, not 8, right? 12 would be 1, 2, 3, 4, 6, and 12, right? What is the highest number that could go into both of these numbers here?
4.
4 is the HCF. Yeah. All right. So there's something I want us to take note of for LCM. It's very useful. You'll just take this up. You should be seeing my screen. When you're finding the LCM of a set of numbers, it's very helpful sometimes to remember or to take or to consider, right, that if one number in the set is a multiple of the others, then the LCM is simply the largest number in the set. For example, the LCM of 3, 6, and 9 is 9. Yeah? Because nine is a multiple of 3. Yeah? Now, if there are no common factors among the set of numbers, right? So there are no common factors, then the LCM of the product, so then the LCM is the product of the numbers in the set. For example, we wanted to find the LCM of 3, 5, and 7. There are no common factors among them, yeah? 3, 5, and 7, no common factors. So therefore the LCM of 3, 5, and 7 will be 105, yeah? And that is obtained by multiplying 3 by 5 and that by 7. So 3 multiplied by 5 multiplied by 7 will give us 105. Yeah? And if there are factors common to the members of the set of numbers, then we could have go ahead and do what we were doing before, list them out. Yeah? All right, so I just want to give you a little exercise here. All right, determine the LCM and the HCF of 24, 36, and 60. I've given you about 4 minutes to work on this. All right, are we able to correct that or look at this one? Yeah, nay. What do we get for the LCM? Mm-hmm. Then help them out, man. All right, so let's try to find. So by using the principles on the left, we know that in terms of finding the LCM, because that's what we're doing now, none of these are a factor of the other. Yeah. So it can't be method 1. Excuse me. And it can't be method 2 either because there are factors that are, common to each other. Yeah? Is that correct? Yeah? So let's see. You have to list it out. So 24 by 1 is 24. 24 by 2 is 48. 24 by 3 is
76.
24 by 4, 96. 24 by 5, 120. Let's do about 7 and see. Yeah. 24 by 6, 140, 144. 24 by 7, 168. You can hold there. And let's see if we get any luck. Going on the factor line for the multiple line for 36, so we get 36 by 1 is 36. By 2 is what?
72.
Mhm. Right, you starting to feel the energy we see in a 72 is a multiple of 36 and it's also one of thing. Let's go down. We know 72 will never be a multiple of 60, so it definitely is not 72. Right? So 36 by 3 is
108.
108.
10 by 4, 144. So we probably thinking, all right, 144, could 60 no, but then 60 and 60 is 120. So we sure it's not 144 either. Yeah. And we have what, 180. Yeah. 180 plus 36, 216. So we had to go up on top as well, right? Uh, 168 plus 24, 168 plus 24, that's 192. 216, 240, shalala. 216 plus 36, 252 plus 36, 288. plus 36, 324, plus 36, 360, plus 36, 396. Good. Now, at this point too, you can start to divide, the numbers into it to see if it will be a multiple. Like you could say 324, and I want to divide that by 60. I get 5.4, so that doesn't work. 360 to be divided by 60, I get 6. Yeah. So I know that somewhere along the line down on 60, I will get 360. So 360 is definitely 1. And let's see if 360 could go in 24. If 24 could go to 360. So 360 divided by 24, I get 15. So 15 places down the line. I'll get 360. 360 here also works. So 360 is the LCM. We agree with that? Anybody got it? Or if I know it's a lot of pressure and stress.
Yeah, it was a lot.
Yeah, it was a lot. Now there's a much shorter way to find it. And I'll show you all that next class. We're looking at prime factorization. All right. What about the HCF? All right, so let's see, factors of 24. 1 by 24, 2 by what? 12. 3 by anything? No. So 4 by 6. Yeah? 5 by anything? No. 6 by anything? But 6 by 4. So good. 1, 2, 4, 6, 12, 24. Good?
Eight.
Sorry?
8 is normal. A factor of 24.
So 8 by what?
8. 3 8s are 24.
3 by 8. Good? So we have 1, 2, 3, 4, 6. Well, you have 8, 12, and 24. Good. Then 36. 1 by 36. What else? 2 by what?
By 18.
3 by what?
12.
4 by anything?
9.
5 by anything?
Nah.
6 by anything?
6 by 6. Yes.
7 by anything?
Nope.
8 by anything? No?
Nah, no 8.
Good. And then 9 by 4 already there. Good?
Yeah.
So 1, 2, 3, 4, 6, 9, 12, 18, and 36. And what about 60? That's 1 by 60. 2 by what?
30.
30.
3 by
20.
20.
4 by
15.
5 by
12.
12.
6 by
10.
7 by anything?
Nah.
8 by anything?
Mm-mm.
9 by anything? And then, well, of course, 10 by 6, yeah? That's 1, 2, 3, 4, 5, 6, 16, 10, sorry, 12, 15, 20, 30, and 60. And then we look for the highest factor common to all of these things, which would be what?
12.
12. Now, yes, the 8 here. Why wouldn't it be the lowest common factor? Because we talk about why it wouldn't be the highest common multiple. Why wouldn't it be the lowest common factor?
Because the name is the highest common factor. I think you like info.
Yeah, but why? Okay, why
It
did
will, it will always be 1 because 1.
it can't be the lowest common factor because 1 is the lowest factor and 1 is a factor in everything. So it will always be 1, right? So that is something that we should keep in mind, right? All right, so next class, we're going to do prime factorization. So I want to take note of that. We're going to look at prime factorization. I'm going to do some questions involving the LCM and the HCF. We're also going to look at fractions. Yeah, so you all have any questions for me before we close up today's class?
No, we okay for now.
Yeah. All right. For now, you'll always be okay, don't worry yourself. Yeah, so we went through quite a bit today. Yeah, we did get quite a lot of work done. Okay. So next week we continue. I will post some stuff in your Edmodo this week as well, so don't fret, look out for that, right? And yeah, we continue next week Saturday. Right? Please, if you're getting difficulty setting up your Edmodo, let me know. And yeah, see you guys. So everybody have a good day.
Okay.
Thank you.